All right, welcome back, everybody. Let's take a look at an example. So this example says, insight into the freshman 15. Researchers at Clareton University in Canada studied a random sample of first-year students who lived on campus and a random sample of first-year students who lived off campus. Data on weight gain in kilograms during the first year are given below. A negative weight gain represents weight loss. So the freshman 15 is essentially this idea that once students go off to college, they tend to gain weight. And I guess this is very precise. The claim is that it's 15 pounds probably. And here we're looking at kilograms. So let's go ahead and notice that this is from 2010. We've got two groups. And so our very first question of what are the parameters of interest, because this is weight gain, I hope you see right away that this is a quantitative variable, and therefore we're probably interested in the mean. And it would be the mean of the corresponding groups. So the parameter of interest would be mu1, which would be the mean weight gain. And this would be for, let's see, what group were we introduced first? Studied a random sample of first-year students. Weight gain in first-year students. Oh, but all of these are first-year students. I'm just realizing that here. They're also first-year students. So we're looking at first-year students, but we're separating them off by the factor of, do they live on campus or do they live off campus? So we're going to go ahead and say that group one would be the mean gateway for students who gain for those who live on campus. And then the second group, mu2, that's the mean weight gain for the students who live off campus. So it's pretty interesting. Is there a difference between these two? Oh, okay. So check out the second part. Many people believe that living on campus leads to overeating since most students on campus have access to a meal plan. So I don't know if that's true or not, but that's the claim. The researchers do not believe this is the case. What is the most appropriate hypothesis to use? Oh, wow. So that's a pretty difficult question. Hopefully you're thinking about it. I sure as heck know what the null hypothesis is going to be. That's simply going to be the hypothesis of no change. So these groups, there is no difference between the weight loss, whether they live on campus or off campus. We're going to assume that they are the same. Now, for the alternative, they kind of started off by saying that it sounds like the people who live off campus, so that would be group 2, that they potentially would have a larger weight increase. But then they switched and said the researchers do not believe that that is the case. So here we have two competing concepts, right? That one is saying that mu2, so the first sentence there says that mu2 would be lower, but the second one says the researchers don't believe that that's true. So then it changes that. So because of that competing nature, I'm simply going to go ahead and say maybe the most appropriate hypothesis, because we can't seem to agree on who would have a larger weight gain, is just the hypothesis of change. So let's go ahead and test whether mu1 is really different from mu2. Remember that StatCrunch is going to go ahead and want these on the one side, so we're going to go ahead and do that as well. So mu1 minus mu2 is 0 versus the alternative, which is mu1 minus mu2 is not 0. So we don't know what it is, but we're just saying it's not 0. All right, next part. Is it reasonable to use Aspen-Welch t-test? I'm pretty sure there's a the missing in there. Is it reasonable to use the Aspen-Welch t-test? All right, yeah, that makes more sense. Now, remember, the Aspen-Welch t-test is the approximation to essentially replacing the population standard deviation with the sample standard deviation. And the requirements are essentially the same. We just need to go ahead and check, are the requirements satisfied? Do we have a big enough sample size, or is my population normal? So obviously I'm going to go ahead and say SRS and independence are more or less a given for each group, but then the shape is not. So let's look at population 1. So population 1 is living on campus. So is my sample size big enough? So let's see, what is my current sample size? Uh-oh. So this is not that big a sample. You see, here's individual 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have a simple random sample of 10 students who live on campus. That's clearly not big enough. So because of that, I need to check, is there weight gain? So the weight gain for students who live on campus, that's the random variable, is that normal? So we need to actually investigate that. To investigate that, we need to use StatCrunch. So I already have my StatCrunch data frame open, so I can just go over to StatCrunch and select graph. We're going to do a box plot of the on-campus. Really, we're going to do it for both. So let me just highlight both. So that's pretty good. Remember, we're looking for outliers. And then we're going to do graph QQ plot. We're on and off. All right, so there's the QQ plot for on campus. We see the correlation coefficient is 0.973. And box plot shows no outliers. So there is evidence for me to say that, yeah, the amount of weight loss that on-campus students, or sorry, not weight loss, weight gain that on-campus students are doing does appear to come from a normal population. So yeah, the weight gain does appear to be normal. That's for population 1. You got to do the same thing for population 2. So I'm not going to write it down. We've more or less already done it. Here we see off-campus. And there does appear to be some asymmetry involved, where there's some slight left skewed, but there are no outliers. And then we can compare to the QQ plot with a correlation value of 0.981. So that's pretty high. So we're going to go ahead and say that there is evidence that this is also normal. So I'm going to go ahead and check that off. So I can go ahead and proceed. Now I need to complete the hypothesis test. To complete it, we need to make sure that we know where we're at in the hypothesis stage. So notice this was parameters. That's number 1. Number 2 was for us to write the hypothesis. Number 3 was verify the requirement. So we're basically at stage 4, where we're asked to sketch the relevant distribution. So to sketch, remember that this for means I'm going to draw a T distribution where the degrees of freedom is the smallest sample size. Lucky for me, the sample size in both cases is 10. So degrees of freedom is just simply going to be 9. I'm doing a not equal to, so that means there's a two-tailed test. And therefore I divide by 2. And I can find my critical value. Now, did they give me an alpha? There is no alpha given, so I'm going to go ahead. Oh, there is actually. There it is, 5% significance level. So alpha is 0.05. And we're going to go ahead and split that in 2, so that's 0.025. So to get our T statistic, we're going to go to StatCrunch. Go to Stats, Calc, because we have the distribution, and then go to T. Degree of freedom is 9. Trying to find the right tail where the area is 0.025. So that's 2,262. All right, so there's our sketch. On the left-hand side, we get the negative of that. All right, and now that I have my sketch, I can go ahead and find the test statistics. So the test statistics will be the t-stat and our p-value. So let's go ahead and find that. Remember, the command is going to be t-stat with 2 samples. So we're going to go to stats, t-stats, 2 samples. Right, sorry about that. Technology was not cooperating. So we're going to stats, 2 sample, and we've got data in this case because we have the data in StatCrunch. We're going to select group 1. So here, be very careful. Make sure that you always have the correct group. So notice group 1 was on campus. So we want to make sure that that goes to group 1. Off campus, that was group 2. So on campus is group 1. Group 2 is off campus. And then make sure that your hypothesis matches. So we have a 0. That's fine. And the alternative for us was not equal to, as we can verify here, not equal to. So we are good to go. Compute. And we get our t statistic and our p-value. Now, this is pretty surprising because you can already see from the p-value that this is 0.2043. Let's write this down. All right, now let me go ahead and throw this into the distribution. So a t-statistic of 1.3, that's very close to 0. So I am not beyond 2.23. I'm right around halfway. So unfortunately, my sample lands in the non-critical region. Therefore, we're going to fail to reject the null. And if we take a look at the p-value of 0.2, there's a 20% probability that this sample, could occur just due to random chance. So that's not significant at all. That's greater than alpha. So that also says fail to reject the null hypothesis. So let's go ahead and summarize this. We're going to write, we have insufficient evidence and usually it's important to tell me like what the threshold for evidence was, but 20% that's not going to be significant at all in any case, right? That's a 1 in 5 chance. So I guess for us right now, we're just going to say evidence at the 5% significance level to support the claim. And really, it would be mu1 is not mu2 in Word. So the claim would be that on campus, first-year students have a different mean weight gain than off-campus students. Wow, so that was actually pretty surprising. So according to that data, there does not appear to be a difference. If you take a look at the actual data itself, you can see that the on-campus, pretty low, most of these students, 2, 2, 1, -2, -1. So those individuals, lost weight. And the rest gained about 5 pounds to 8 pounds. And if we compare the off-campus, we do have some weight gain of 1, 3, right? No weight gain, small weight gain. And then some small weight loss, but then there's a weight gain. So overall, the weight loss and weight gain seem to cancel out. We don't have significant evidence to say that these are that much different, unfortunately. All right, and so that does it for that hypothesis test. Now there are more parts here for us to do. So part E says, let's construct a confidence interval. And remember that a confidence interval, you already know how to compute because you're simply going to go and change the output. You're going to say, I just did a hypothesis test. Let's edit that to what happened? Let's edit that to a confidence interval. And let me just verify this. Alpha is 5%. So yes, 95% confidence. So let's go ahead and press compute. So I have my lower limit and I have my upper limit. All right, so let's write that down. So we constructed the confidence interval. Remember, this is a confidence interval for mu1 minus mu2 is between the lower limit, which was minus 0.975, and the upper limit of 4.195. The most important thing to notice here is that my confidence interval goes from a negative to a positive. And so unfortunately, they're not the same. So 0 is contained in this interval. And so what that refers to, what that means is that it is possible that mu1 minus mu2 could actually be 0. And notice that that was the null hypothesis right here. So that null hypothesis, that mu1 minus mu2 being 0, that is potentially true as shown here by our confidence interval. So because it's possible that mu1 minus mu2 equals 0, this supports the conclusion of the hypothesis test. We're only able to reject the hypothesis test if the lower limit and the upper limit have the same sign, in which case that tells you which of the parameters is larger, right? Either the negative one or the positive one, the one that has the negative coefficient or the positive coefficient. There's one last part here that says draw side-by-side plots, just to determine whether that supports our result above. So the claim is there is no difference. So let's just visualize this. So I'm going to do graph. Oh, we kind of already did it. Box plot, on campus and off campus. And let's do these side by side. And let's actually visualize the means. This is something that we'll do later on in chapter 13 as well. So it looks like there's a slight difference in the means. This is what we were doing when we started the class, but more qualitative, where we said, oh yeah, the average for on campus is slightly higher than off campus, but now we know that this is not statistically significant, right? The on campus appears slightly higher, but it's not statistically significant. So we now know it's not significant, but it does appear that the on-campus tends to be higher. We were not able to show that statistically, so unfortunately, we cannot say that from this picture. We probably believed at the beginning of the class that on-campus would actually result in a higher population mean, but our sample does not support that. Okay. All right. So hopefully you start seeing how our class is coming full circle to everything we did at the very beginning. This is it for the example. So hopefully it made sense. And if it did not, please make sure you reach out.